Okay, so we've looked at measures of central tendency, which basically refers to characteristics of a data set to cluster around an average value, to cluster around an average value. But data sets also have a unique characteristic where the values of the data set differ from the central value. Each value of the data set differs from the central value, and what those differences look like is what we refer to as measures of dispersion. So what are they? Another word for dispersion is variability. So measure values of a data set, while those values would tend towards a central value, they will also vary from the central value. There will be differences between the central value and each individual value in the data set. So how we measure that difference, the dispersion or the variability, is called measures of dispersion. The measures of dispersion are very important because when you are looking at the relationship between variables or between phenomena, you want to look at the relationship in terms of how it comes towards a central value, but also how it disperses. From very simple one to the ones that are a bit more complex, you have a range. And along with range, you have interquartile range. You have deviation. You have variance. You have standard deviation. And you have coefficient of variation. There are a couple of other ones. So you can have percentiles as well. So let's look at them one after the other. Simple, range. The simplest. What is range? In statistics, it is the difference between the largest and smallest values for every observation in the sample. In English, range means the smallest value to the largest value. That's English. Or maybe that's mathematics. I don't know what it is. But in statistics, range is the largest value minus the smallest value. It just shows you what the variability in terms of the difference in the value of the largest and compared to the smallest value. More often times, the range will be bigger than the sample size. Many times, it is not very reliable because if you have what we call outlier variables, where you have very high or very large or very low values, you can have a very large value as your range. You may not really be able to do so much with your range of values. It just tells you how widely dispersed your values are. The smaller your range, the less dispersed. The larger your range, the more widely dispersed. Let's look at interquartile range. So with interquartile, the word quartile is a fourth. You divide the sample size by 4. So what you are dividing is not the values, you are dividing the order. Remember, when we're talking about media, we said you must rank first. There must be an orderly distribution of the values. The same thing with interquartile. Remember, see range, you have arranged the values from the smallest to the largest, so that at a glance you can pick the smallest value, pick the largest value, and do your subtraction of the smallest from the largest. That same arrangement needs to go into interquartile range, where you will now have a ranking from the first number to the nth number. If the sample size is 20, the nth number will be 20. If the sample size is 30, the nth number will be 30. then the formula is n plus 1 divided by 4. N plus 1 divided by 4. And then that gives you the quarter. And then you now divide that data set into quarters. 4 quarters. 4 quarters. So you have your first, second, third, and fourth. Now look at it. Your first is the lower value for your range. Your first is the lower value for your range. Your fourth is the higher value for your range. So what we call the upper and lower are the ones in the middle, second and third. Second and third. All right. That's what we call upper and lower quartile. So it's not as sensitive to outliers because it doesn't include those outlier values. So it cannot be moved by those outlier values. It will help you get some more sense, some better sense of how values vary. One of the principles that you will learn in statistics, and I mean, if I or Dr. B or somebody else goes ahead and teaches you inferential statistics, one of the things you will learn about variables, the values of variables, especially biological related variables. The values of these variables tend to have a clustering around a central tendency, an average number, and tend to have a dispersion. So at the ends, the lowest and the highest, you may have very high or very low numbers, but somewhere in the middle, those numbers are very similar to each other. Majority of the sample size, majority of the population will have values that are not too different from each other. The difference, the distance, the dispersion is not so much. The distance, the dispersion is not so much. So that you need to take that into and just have that at the back of your mind as we're discussing that. So lower and upper is actually the second quarter and compared to the third quarter. That explains to you what that difference is your interquartile range. All right. Deviation. For you to calculate deviation, you need to know your mean. The first thing to do is to calculate your mean. What is your mean value? Once you know your mean value, the difference between every value in the sample and your mean value is a deviation. So for example, if your mean value is 5, let's assume, let's use something that is more realistic. Let's look at weight, the weight of people in your class, and you have a mean weight of 55 kilograms. But somebody weighs 58 kg. Somebody else weighs 52 kg. Somebody else weighs 53 kg. Somebody else weighs 61 kg. The deviation for each unit, the value of each unit, you can calculate the deviation by subtracting that value from your mean. Subtracting your mean from that value. Subtracting your mean from that value. So for example, I've said the mean is 55. Somebody who weighs 52 kg, the deviation is 52 minus 55. And you know that gives you a negative number. That is minus 3. That's your deviation. Somebody who weighs 58 kg, what do you do? How do you calculate the deviation? 58 minus 55, that is the mean. It gives you a positive number plus 3. So you do all of that for each of the values. Now we are going to find out something pretty, it may sound astonishing, but something pretty straightforward if you know mathematics. That if you add up all the deviations, the sum of the deviations will be 0. because you have negative values, you have positive values. By the time you put all of them together, they will all cancel out quite nicely. And what you will find out is that the sum of all deviations around the mean will be zero. Will be zero. So if we want to use deviation for measure of dispersion or measure of variability, we need to do something to that deviation. We would often square it. That's where that square comes. Those of you who are familiar with the formula for standard deviation or for variance, you will see a square. You will see a squared. Right? So what is variance? Is the average of the squared deviations from the mean. It is the average of the squared deviations from the mean. So each of those deviations, -3 plus 2 minus 10, like all of them, you add them up. You add them up, but you square it so that that's zero. So -3 squared plus -2 squared plus -10 squared plus 6 squared plus 5 squared. And you know, minus times minus will give you a positive. So you turn all of them to positive and then you square it. Then you divide it by the sample size -1. Sample size -1. And this is why not divide by the sample size? Why sample size -1? Why not just divide by the sample size? N is sample size. Anytime you see small n, it is sample size. You see big N, it is population size. And there's a difference between a sample and a population. A sample is a subset of a population. Population is the entire, everybody, every unit that can ever exist will exist in the population. You can't study everybody, so you take a subset of it and that's your sample. So why are you doing n-1? This is what is called degree of freedom. Now, the theory of degree of freedom is that not every value, almost every value in the data set has an opportunity to vary from the mean except one. Almost every value in the data set has an opportunity to be different from the mean except one. There is always a middle number, which is either the mean or the median in some cases, that cannot vary. It can't change. So you can't use it in calculating variability or calculating variance. So you subtract it, and that's why you have n-1. This is where the theory of degree of freedom came from, for those of you who have some, advanced knowledge about statistics. So S squared is variance. Each of the deviations multiplied, squared and summed up. Each of the deviations squared and summed up, divided by the total sample size -1. The total sample size -1. That gives you your variance. It gives you your variance. What does variance tell us? Not much, because it's squared. It's squared. And squaring was for convenience, to be able to deal with negatives and positives that are canceling each other out. It's really not valuable. So what is valuable to us is standard deviation, which is the square root of variance. So whatever, see the formula for variance is similar to the formula for standard deviation. The difference is that this S has lost its square, and this has gotten a square root. So this is the origin of the formula for standard deviation. Summation xi, which is individual values, minus x bar, which is the mean value, squared, divided by degree of freedom, sample size minus 1, square root, square root. How does this help us? How does this help us? Standard deviation helps us because it gives us one of the most accurate measures of variability. One of the most accurate ways of understanding how values vary from the mean, from the measure of central tendency. Okay. So a coefficient of variation is also a measure of dispersion, and it simply expresses the standard deviation as a percentage of the sample mean. The formula is there, standard deviation divided by the mean times 100. Standard deviation divided by the mean times 100. That's your coefficient of variation. And all this become useful when you are doing inferential statistics and you want to know when you want to use statistical tests. All right, I'm going to check this. Okay, so this is just giving you some overview, of measures of central tendency and measures of dispersion. Some overview of measures of central tendency and measures of dispersion. All right. Good enough. We'll share the recording so that you can watch it again. And I'm very sure from what the class rep has said, Dr. Abi will may likely take it, even though I'll tell him that I have what I have done so far. So he may want to take something else. All right. Yes, I would share the soft copy of a textbook for starting one or two textbooks. With you. Yeah. Coefficient of variation is the standard deviation divided by the mean times 100%. The standard deviation divided by the mean times 100%. That's coefficient of variation. An outlier is a value that is much higher or much lower than the typical values in a data set. And I told you, typically values in a data set want to cluster around the central tendency. So, yeah. So we'll learn about standard error when we talk about inferential statistics. We'll learn about standard error. Yes, I'll share my slides. That's not a problem at all. Interquartile range, the difference between the second and third quarter. There are 4 quarters, first, second, third, fourth. The difference between the second and the third quarter. Lower and upper. All right. I think we can call it a day. You need it because you need to understand how variables differ from the central tendency. You need to understand how variables differ from the central tendency.